So today's LeetCode problem, maximum product of first and last elements of a subsequence. So what does the problem statement say? You are given an integer array nums and an integer m. Return the maximum product of the first and the last element of the subsequence of nums of size m. So what does it mean is, let's say this is the problem statement. This is nums given to us, -1, -9, 2, 3, -2, 3, -3 and 1, and m equal to 1. So you need to return a subsequence of length m equal to 1 where the product of first and last element should be maximized. Let's say I took -1, so m is 1, so the subarray size or the subsequence size, not subarray, subsequence size should be 1. So -1 into -1 will give me 1, -9 into -9 will give me 81, which will be the maximum. And you can try in all nums, this will be the maximum one out of it. So the one thing which might be leading to other thought is a subsequence is given, so should we try DP? No, it's not a DP problem. Let's understand this with a test case. Let's take up this test case. I have written it here. So what I am thinking is, let's say we are given a nums 1, 3, -5, 5, 6 and 4. So what is the observing thing over here? Let me copy it and paste it here, right? So I can do this. So what is the thing which we need to take care of? If our nums is this, let's say if we take our first integer as 1, so what should be the next integer so that the answer is maximized? See, m is of length 3, so you can take up any element, any subsequence which is of length at least 3. You can take 1, you can take 3 and -5, you can take 1, -5, 5, you can take 1, 5, 6, you can take 1, 6, -4, any subsequence you can take, and you need to maximize it, right? So what you can observe here is, if you somehow get your last element as 6 now, it will maximize your result, right? So let me explain how you will get a 6, right? Let's say you took 1, you took any element in middle, it doesn't matter what element you take. You can take -5 as well, you can take 5 as well, you can take 3 as well, and after that the last element should be 6, thus making the subarray of size subsequence of size 3, and the product is 1 and 6, which will at least in this, for this one, the maximum we can get is 6, right? Let's say if we took 3 as our element, right? So what will happen? For 3 we can take any subsequence, and just by observing you can say, if you took 3 and a 6, the product will be 18 and it will be maximized, right? Let's say you took 3, what are the subsequence which are possible? Let me erase it. Okay. So if we take 3, right? So what are the subsequence which are possible? You can take 3 and 6. If you anyhow take a 6 now, that will maximize your answer, right? So 3 and then let's say -5, and then you can take a 6, right? So and 5. So these are the possible subsequence which are there, and you will get a result of 18. This is also not maximum. Then what is the maximum that we can get? Let's take if we take -5, let's say, then if it's a negative number, what we can observe is, if you take a negative number and you want to maximize it, the next element should be negative as well, or it should be as low as possible, right? Because let's say if you took -5, right, and you took a positive number 6, so it becomes -30, right? -30, which is very small, right? Instead, if you took -5 and a -4 somehow, then it becomes 20, which will maximize our answer. And I guess that is our answer, right? 20 is the maximum which we can get. I will do a dry run on it, don't worry. So let's see what is our logic behind this. So from these, what we can observe is, for a positive number, you need to find the maximum element which is on its right of at least distance m equal to 3, right? Let's say 1. So you need to have one in your subsequence and any two elements, more two elements, such that the size of the subsequence is at least 3. So from up to this point you can easily take any subsequence, or rather from starting from this point till the end you can take any subsequence, and that will, and from that if you somehow find the maximum element out of it, then it will give you the maximum answer for starting with this element. Getting it? If not, let's say I was standing at 1 now, so I can start from -5 and go till the end and find the maximum element which is there, and multiplying it with that element will give me the maximum result. Let's say 6, so answer becomes a 6, right? So what we can observe is, thing to notice is that if your nums is greater than 0, then you should choose from the right at least of distance m minus 1, so that your result is greater than 0. So you need to choose from towards its right of size m minus 1. Why m minus 1? Because one element you have already chosen, right? Let's say you are standing on this index, so you choose this index, and after this you can go on the right of size m minus 1 and choose any element which is greater, which is maximum, right? And the second thing is, if you have a negative element, right, if you have a negative, then what you need to do is you can choose any element which is the smallest. So for a negative you need to find the smallest on its right, which is at least m minus 1. That's it, right? So this was the core logic of the problem statement. Now let's see what I have done. So that the thing which we can use here, right, is, let's say this was our nums, right? Let's take a red color. So this was our nums, right? And what I know is I need to find the maximum element to the right, right? Maximum element to the right. So why not start from the end of the array and store the maximum element which are there. So if it's minus, let's say here till this point -4 is maximum, here -6, -6, -6, -6, -6, right? These are the values which the positive can store, right? And similarly, what is negative storing? Negative store is storing the minimum element from right only, right? So let me erase all of these. So let's say 4, so -4 is the minimum here. Till this point -4 is minimum, till this point -4 is minimum, -5 is minimum, and till the start point -5 will remain the minimum. Now what we need to do from it, right? So see, let me be little patient over here. Let's say this is our answer array, right? So what I will say is, if we start with a 1, right? If we start with a 1, then of at least size m minus 1, so this is 0, so m minus 1 is 2, right? So up to this index, from this index what is the maximum? So we have already stored it, right? 6 is the maximum at this point. If you go to the right, you will find 6 as the maximum. So you can find out the maximum in O of 1 time, right? Why O of 1? Why not we can't traverse in the whole array? Because of the time constraints which are there. The time constraint is 10 to the power 5, right? So you cannot run from again, right? If you run again on the for loop, it will make the time complexity as O of n square. So you need to calculate the maximum to the right in O of 1, and for this we have stored the positive maximum and negative maximum like this, right? So you started with a 1, right? And what we next did was, from this m minus 1 distance, you will simply in O of 1 you will calculate what is the maximum to the right, which is 6 over here. So for the first element the maximum comes out 6. For the second element, which is 3, again what you will do, you will say m minus 1 from this. See, it is a positive element, so you will check in the positive vector, right? You will check in positive vector. So you will say from this point I equal to 1, let's say, right? I equal to 1. So m minus 1, which is this till this point, what is the maximum over here? 6 is maximum, so 3 into 6, it will give me 18, right? And again -5. So -5 in which vector you should check? In negative vector you should check, right? So m minus 1, which is this point, right? So -5 into minus 4 which you got is minus 20, right? I will do the complete dry run of the problem, so it becomes 20, right? Okay, it became little clumsy, right? So let's say 5, right? For 5 what you can check, m minus 1, which is this. So last element. So what is the max, sorry, what is the maximum? It is a positive number, so you should check in the positive vector. So minus 4 is maximum, so 5 into minus 4, which is minus 20. So these are my possible answers, and I will calculate what is the maximum. So maximum is 20, which will be my answer, right? So this was the whole statement, right? Why we calculated positive and negative? Because we didn't want to travel in O of n square. So just to save time, we did it O of n. We are traversing on O of n, and for calculating the maximum, we are taking O of 1, which is ultimately O of n time complexity, right? Now quickly let's see the code. So what I did is created, let me, yes. So what I did, so now let's quickly discuss the coding part. So what if m is equal to 1, means if a subsequence of size 1 is only given, like the first test case. So what you can do is simply check which element multiplied by itself will give you the maximum result, right? So for n I equal to 0 to I less than n, I plus plus, you will simply check 1 LL into the number multiplied by itself and store it in your answer maxi, right? And after that what we are doing is we are simply storing our positive n minus positive vector, which stores the positive from the end of the array, right? It's, I guess it's pretty clear why we are storing from the end, right? So pos of I equal to max of pos of I plus 1 and nums of I, maximum of these, right? Let's say if we are standing at this, right? So positive of last element is minus 4, then 6, because this is the maximum. So what I am doing is I am checking this element with the positive of I plus 1, right, to store the maximum out of it. And similarly for the negative, what I am doing is I am storing the minimum, right? I said why we are storing negative minimum in the negative, because for any number which is less than 0, we need to store the minimum value on the right side, right? Okay, so after that what we are doing is I simply set, right? So for n I equal to 0, I less than equal to n minus n. Now why n minus n? Because let's say our subsequence, we are standing at this position, right? Let's say 6, right? So 6 is the 0, 1, 2, 3, 4th index, right? And 4 plus, you need to add m minus 1, you need to go at least m minus 1 elements for the, right? So 4 plus 2 will give you out of bounds, so there is no use to check beyond n minus n, right? मतलब कोई फ़ायदा नहीं है ना, राइट? लेट्स से यू आर स्टैंडिंग एट 6, तो इसके आगे 2 एलिमेंट आगे तो कुछ है ही नहीं, तो इस एलिमेंट तक जाने का कोई तो मतलब ही नहीं बनेगा ना. So that's why we are going till n minus m only, right? And we are simply doing what we discussed. If nums of I is greater than 0, then we will store we will check in the positive that what is the maximum. This will give me in O of 1 time, right? This will give me in O of 1 time only, that what is the maximum. Simply it will give me, right? So I will just say what is the positive number which is the maximum after this point, I plus n minus 1, right? Let's say 3. तो 3 के लिए पॉजिटिव कहाँ से मिलेगा मेरे को? 3 कितना पोजीशन पे है? फर्स्ट पोजीशन पे. तो 1 प्लस 3 माइनस 1, सो अल्टीमेटली थर्ड पोजीशन के बाद. तो 0, 1, 2, 3. तो इसके बाद मैक्सिमम क्या था? मैंने स्टोर करके रखा है 6 है, राइट? सो वो सिंपली चेक करके चला जाएगा आगे वैल्यू, और अगर नेगेटिव होगा तो वी आर स्टोरिंग दैट एज वेल, एंड मैक्सी विल बी मैक्सिमम आउट ऑफ ऑल दीज, एंड वी विल return the maxi in the end. So what is the time complexity of this code? So we are running O of n for every element, right? For this one we are running O of n, and these are being calculated in O of 1. So O of n into 1, so it will ultimately give O of n, which is in our time constraints, right? 10 to the power 5, so it is easily in our time constraints. That's it. So I guess you enjoyed the video. If you do, please like and subscribe, and if you have any doubts in this, you can definitely ask me in the comments. Thank you for watching.